All right, for those people that decided to be here today, let's see. So, class?
Yes.
Thank you. Now, yesterday I ended the notes early because I wanted you to try the practice. Okay, I appreciate that. And so today we're going to just work on this practice here. So this set of notes, we're going to apply what we learned yesterday. So doing the chain rule. So another way of actually saying it is working our way from inside to outside. So in class here, for those people that are not here, we took the complicated part, right, and we use that as our U. Now we could say it's the same thing. So now this one right here, it would be inside, but if you notice, there's no really an inside on this, right? So the e to the 4x is my problem. So the complicated part to this is that 4x, isn't it? So I'm going to actually do that. So I'm going to say that u, in this case, is my 4x. U prime is 4. So I now have y equals 5 e to the u. Yeah? Y prime is equal to 5 e to the u times u prime. So rewriting it, it's now y prime is equal to 5 e to the 4x times 4. So y prime is 20 e to the 4x. So there we go. So I have the derivative. Now, what does the derivative give me? Not of the tangent line, it's slope of the tangent at a point, right? Yes. So it's going to give me the slope at any given point. It's going to give me the slope at any given point, and that's what we use for the tangent line.
So tangent is just like the general term. Tangent line is specific.
The whole line. The tangent line is the y equals mx plus b.
And the one at a specific point.
Yes.
Okay.
At that point. So any given x. So we don't always use the tangent line. When we're talking about using it in physics, we talk about my first derivative gives me the velocity. So at a certain time in physics, I don't want to know the equation of the tangent line. I want to know what is the velocity at that point, right? So that's what the derivative is going to give me if I'm using the physics portion of this, right?
So it means the same. It's the same value but different meaning.
Yes, but you're not going to try and find the tangent line. You're just finding the slope at that point. And that's what we're doing right now, right? So this is going to give me the equation for the slope. So right here, find the equation of the tangent line now, and it's given us a point, 0, 5. So that means that my x value is 0, my y value is 5. So let's go ahead and plug that in. So when y5, so y prime of 0 is going to give me anything to the 0 power is 1. Anything to the 0 power is 1. So 1 times 20 is 20. So in terminology for this, okay, the slope when my x is 0 is 20. Another way of writing this, so you could actually, maybe this might help. So this would be m is 20. If that notation actually helps you out.
What was that equation again? There is
I'm going to put it up here in a second. So we got slope is 20 right there, right? Okay, so my y minus y1 equals m quantity x minus x1. There we go. Now, this is point slope. So depends on what's given to me. If I have a point and I had a slope, I'd use point slope. All right, so now I'm going to plug in these values. So y minus 5 equals 20 times quantity of x minus 0. Y minus 5 equals 20x. Add 5 to both sides, so y equals 20x plus 5. Yeah, that's given to me there.
Then I was gonna ask about the equation for the m, the derivative, isn't it fx minus fc over x?
Yeah, yes, you could do it like that. That's using the what process? That's the limit process right there. Yeah, that's the limit process. But we don't want to do the limit anymore because now we got something easier. You can just do the derivatives now, right?
I just like try to like to.
It's all right.
Will we ever use it again?
Yeah. Yeah. So when you get to Calc 2, one of the units you're going to do is actually going to be series and sequences, and you're going to do like summation of some values raised to some like of something. All right. So, and I think that one's it for the ones I was actually trying to get you. Yep. I'm going to leave that one alone. We're going to pick that one up tomorrow. You guys now have a little bit more you could be doing, right? So if you didn't finish that first page, you get, or you did, so I want you to finish that first page. If you flip over to the second page, you should have some problems that actually have to do with equations of lines. All right, like, share, and subscribe.